Good morning, students. This is Latif sir. Today I am going to discuss about the first chapter of class 10th chemistry. The topic is periodic table, periodic property and their variation. So in class 9 you have already studied about periodic table. Okay. So this is the longest long form of modern periodic table, and this periodic table is made by Niels Bohr and Henry Moseley. You have already studied in class 9. Henry Moseley gave the modern periodic law, that is chemical and physical properties of elements are periodic function of their atomic number. Okay, and based on atomic number this periodic table is made by by Niels Bohr and IPAC. Okay, so this is the longest form of modern periodic table, and in this periodic table there are some groups and some periods. And there are total 18 groups and 7 periods. Okay, so first is salient feature of modern periodic table. Groups, you know what are groups. The modern periodic table has 18 vertical columns, and these vertical columns are known as groups. So there are total 18 groups, and each vertical column accommodates elements with the same number of electrons in the outermost shell, and these vertical columns are known as groups, arranged from left to right in the order of increasing atomic number. So first group 1. Group 1. Group 1. These elements are known as alkali metals, except hydrogen, as they form strong alkali with water. These are also called alkali metals. Group 1 elements, that is except hydrogen, lithium, sodium, potassium, rubidium, cesium, these are also known as alkali metals. Okay, because they form alkali with water. Next, group 2, which is also called alkaline earth metals. Group 2, that is uh, the elements are beryllium, magnesium, calcium, strontium, barium and radium. Group 2, beryllium, magnesium, calcium, strontium, barium and radium. These are group 2 element, and they are also called alkaline earth metal. Okay, and they form weaker alkalis as compared to group 1 elements. And group 3 to 12, they are also called transition element. All the elements of these groups are metals, and they have two outermost they and they have their two outermost shell incomplete. That's why they are called transition element. Okay, they have outermost incomplete shell. Group 3 to 12, that is this portion of the modern periodic table. Group 3 to 12, group 3 to 12 is known as transition metal elements. And group 13, that is boron family. Boron is the first member of this group. And group 14, that is carbon family. Group 15, nitrogen family. And group 16, oxygen family, which is also known as chalcogen. Oxygen family, this is also known as chalcogens. Chalcogens means they can form ore, that is meaning ore forming. Chalcogen meaning ore forming. Okay, and group 17, halogen means salt former. They can form salt like sodium chloride. Okay, these are also called halogens. So group 17 elements. And group 18, zero group, these are all the elements of group 18 are also called noble gases or inert gases. Okay, so let's see. Group 13, boron family. Boron, aluminum, gallium, indium and thallium. Boron in aluminum, gallium, indium and thallium, this is boron family. And group 14, that is carbon family. Carbon, silicon, germanium, tin and lead. Carbon, silicon, germanium and tin, lead, this is group 14. And group 15, that is nitrogen family, nitrogen, phosphorus, arsenic, antimony, and bismuth. This is nitrogen family, group 15. And group 16, uh, oxygen family. Group 16 oxygen family, also called chalcogen, meaning ore forming. Chalcogen family, oxygen, sulfur, selenium, tellurium, polonium. uh, okay. And group 17 halogen family. Group 17 halogen family, the elements are fluorine, chlorine, bromine, iodine, and astatine. Fluorine, chlorine, bromine, iodine, and astatine. You have to remember the name of the element in a particular group. And group 18, also called zero group, the elements are helium, neon, argon, krypton, xenon, and radon. These are noble gases: helium, neon, argon, krypton, xenon, and radon. Okay, group 18 elements are also called noble gases or inert gases because they do not react with any other elements generally, because they have outermost filled shell. Now say, note that the elements of group 1, 2, 1, 2, 13, 14, 15, 16, 17, 1, 2, 13, 14, 15, 16, 17 have 1, 2, 3, 4, 5, 6, and 7 electron in their outermost shell respectively. And this group, that is group 1, group 2, group 13, group 14, group 15, group 16, and group 17, these elements of these groups are known as representative elements or normal elements or ideal elements. Okay, group elements of group 1, group 2, group 13, group 14, group 15, group 16, and group 18. These elements are known as main group elements or representative elements or ideal element. Now see periods. I have told already the horizontal rows in the modern periodic table are known as period. And there are 7 horizontal rows, that is 7 periods. Okay, and the number of cell present in an atom determine the period. So how to determine the number of period? Number of cell present in an atom determine its period. For example, element of period 1 have only one cell, element of period 2 have only have two cell, and that of period 3 have three cell, and so on. Okay, you can see the period 1 is the shortest period because only two elements are there in period 1, hydrogen and helium. Okay, hydrogen and helium, these two elements are present in period 1, that's why this is also called shortest period. So period 2, short period, and it consists of 8 elements. Beryllium to it consists of 8 elements: lithium to group 2, lithium to neon, that is 8 elements. And period 3, short period, second short period, which consists of 8 element, and from sodium to argon, sodium to argon, 8 elements are present in third period. Period 4, that is fourth period, which is also called long period, which consists of 18 elements from potassium to krypton, potassium to krypton. And group period 5, long period, it is also called long period, it is also consist of 18 elements from rubidium to xenon. Okay, period 6th, longest period, which consists of 32 element from cesium, 32 elements from cesium to radon. And last period, that is period 7, which is longest period, and which is also called 32 elements from francium to og. Okay, so these are some description of periods. There are 7 period. First period is shortest period, and the second period is fast short period. Third period is period 3 is short period, and fourth period is long period. Fifth period is also long period, and sixth period is longest period, and seventh period is longest period, also longest period. And the number of elements in each period is also mentioned here. Okay, note that lanthanide elements, these are called lanthanide and actinide. These are present in third period here. In lanthanide and actinide elements are present in third group, group 3, and period number 6th and 7th. In 6th period and third group 3, in group 3 and 6th period lanthanide elements are present, and in group 3 and 7th period actinides elements are present, it is mentioned here. Okay, so lanthanide, which are also called rare earth element, they are present in group 3 and 6th period. And actinide, which are radioactive, all actinides elements are radioactive, and they are also present in group 3 but 7th period. Okay, and they have similar properties because they belongs to same group, group 3. And these lanthanide and actinide elements, they are shown at the bottom of periodic table. They are shown at the bottom of periodic table because they are large in number, and if shown in the main body of the periodic table will distort the shape of the periodic table. And the period 3 elements, the third period elements, that is sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. Third period elements, that is sodium to chlorine, summarize the properties of their respective groups, and thus the third period elements, that is sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine, these are also called typical element. So you have to remember an example of typical element. Okay, I have already told that a period is determined by the number of cell. A period is determined by the number of cell, and a group is determined by the number of electron present in the outermost cell. A group is period is determined by the number of cell, and a group is determined by the number of electron present in the outermost cell. For example, sodium has 11 electron, atomic number 11, that is sodium has 11 electron, and its electronic configuration: 2 electron in first cell, 8 electron in second cell, and 1 electron in third cell. That is, in K cell 2 electron, L cell 8 electron, in L KL M cell, in M cell 1 electron. So in sodium there are total 3 cell are present, 3 orbit or 3 cell are present. Okay, that's why sodium is third period element. Okay, so sodium is third period element, and as 1 electron is present in the outermost cell of sodium, so sodium group number of sodium is group 1. Okay, so sodium is group 1 element and third period element. Similarly, if you see the electronic configuration of calcium atomic number is 20, so 20 electrons, and the electronic configuration of calcium is: in K cell 2 electron, L cell 8 electron, M cell 8 electron, and in N cell 2 electrons. So at electronic configuration of calcium is 2882. So there are total four cell, so period number is fourth period element. Calcium is fourth period element, and as 2 electrons are present in the outermost cell of calcium, so group number is 2. So calcium is fourth period and second group element. Okay, now see what is periodicity. Periodicity, the properties that reappear at regular interval, or in which there is gradual variation, that is increase or decrease at regular interval, are called periodic properties, and the phenomena is known as periodicity of element. Very important term, you have to remember. You have to remember the description of different types of groups, that is group 1 alkali metal, group 2 alkaline earth metal, group 17 halogen, group 18 noble gases, like this. And what are typical element, what are representative element, what are transition element, and their group number also, and which one is shortest period, which is longest period. Okay, and now periodicity, I have told what is periodicity is the properties that reappear at the properties that reappear at regular interval or in which there is a gradual variation, that is increase or decrease at regular interval, are called periodic properties, and the phenomenon is known as periodicity of element. And now see cause of periodicity. The cause of periodicity is the uh, same number of electron in the outermost cell in a particular group. This is the cause of periodicity. Okay, the cause of periodicity is the recurrence of similar electronic configuration. Cause of periodicity is the recurrence of similar electronic configuration, that is having same number of electron in the outermost cell. Okay, and you know that in a particular group, electron in the outermost cell remain the same. Electron in the outermost cell remain same. In a particular group, electrons in the outermost cell remain same. That is electronic configuration, outermost electronic configuration in a particular group is similar. That's why, since the chemical property of element depends upon the number of electron in their outermost shell, chemical properties, remember that chemical properties of an element is depends upon the number of electron in their outermost shell. Thus, elements of the same group have similar properties. Okay, so the cause of periodicity is the recurrence of similar electronic configuration. Okay, so now for example, group 70 elements, that is halogen. All these halogen have 7 electrons in the valence shell. Okay, and therefore they show similar properties, such as they are uh, colored non-metal. They form negative ion carrying a single charge, that is like Cl minus, F minus, Br minus. They are very reactive. Okay, and therefore found in combined state. There's some similar types of chemical properties of halogen, because they have all halogen atoms have same number of electron, that is 7 electron in the outermost shell. So it is thus concluded that periodicity is due to the same number of electrons. periodicity is the same number due to Periodicity is due to the same number of electron in the outermost orbit of different element in a particular group. Okay, now say cell or orbit. Orbit or cell. Electron revolve around the nucleus in certain definite circular path, which are called orbit. Okay, and the cell are also called orbit. And now number of cell, down a group, that is from top to bottom, the number of cell increases successively, that is one by one, such that the number of cells that an element has period equals the number of the period to which that element belongs. You can see here these are group 17 element: fluorine, chlorine, bromine, iodine, astatine, and their electronic configuration are also given. In fluorine, two cells are there. In first cell 2 electron, in second cell 7 electron. So fluorine is a second period element, because two cells are present in fluorine. Chlorine, total 3 cells are there, so it is third period element. And bromine, there are total 4 cells, so fourth period element. Iodine, fifth period element, because total 5 cell in iodine. And in astatine, total 6 cell are there, so it is sixth period element. And you can see from this electronic configuration that all the halogen atoms have same number of valence electron, that is 7 electron in the outermost cell. Okay, that's why their chemical properties also similar, because they have the same number of electron in the outermost cell. And now across the period, how the number of cell changes. Okay, I have already told that down a group, that is from top to bottom, number of cell increases successively, that is one by one. But across the period, that is from left to right, on moving from left to right, in a given period, the number of cell remains same. Remember that on moving from left to right in a given period, the number of cell remains same. For example, in second period, the number of cell remain 2, that is equal to the number of the period. Similarly, in third period, the number of cell remain 3. and so on. Okay, so along across a period, number of cell do not change. Now see valency. Valency denote the combining capacity of the atom of an element, and it is equal to the electron. It is equal to the number of electrons an atom can donate or accept or share. Valency denotes the combining capacity of the atom of an element, and it is equal to the number of electrons an atom can donate or accept or share. On moving down, you know that on moving down down a group, the number of electron in the outermost shell, that is valence electron, remains same. Therefore valency in a group also remains same. Remember that valency in a group remains same, because on moving down a group, the number of electron in the outermost shell remains same. That's why their valency also same. But in a period, in a given period, the number of electron in the valence shell increases from left to right, but their valency increases up to group 14, that is where it is become 4, and then it is again decreases, that is in group 17 it become 1. Okay, so valency on moving down a particular group remains same, but in a given period valency and from left to right first increases and then decreases. Okay, and cell number of cell along number of cell down a group remain down a group, number of cell increases one by one, and from left to right, moving from left to right across a, that is across a period, number of cell remain constant. Okay, thank you student.